Example 1, find two numbers whose difference is 100, whose product is a minimum. Okay, so what you have here is, it says find two numbers. They don't specify the numbers are the same numbers, so therefore we're going to assume they're different. Anytime you're going to identify numbers as different numbers, you represent one as one variable, x equals one number. I use the hashtag symbol to represent number because that's how I used to do it, and it's easier to do that than just write the word number out. So I'm going to do that. One number, and let's say y is the other number. Twitter has hijacked my number symbol and called it a hashtag, but yeah, that means number in my book. All right, one number, other number. Find numbers whose difference is 100. Okay, difference means to do what? Subtract. So I take one of the numbers minus the other number, I get 100. It doesn't matter which one I'm subtracting because it doesn't matter which number is which. All right. At this point, though, by writing it that way, I've established that x is the bigger of the two numbers, right? Right. We want the product to be a minimum. Okay, so now, anytime you're doing an optimization problem, they're going to tell you to make something into a minimum or maximum, and what you're going to do, as far as what you're making minimum or maximum, is going to establish how you're going to write this equation out. So, we want to minimize a product of what? What are we minimizing the product of? The two numbers we're multiplying, right? So, I want to write out an expression representing their product. The product of the two numbers is simply going to be x times y. Okay. Every time you do an optimization problem, they're going to specifically say, minimize this thing, maximize this thing. Okay, they're not going to say it in those words, but they're going to ask you to minimize or maximize something. Okay, you want to write an equation that represents what that is. Okay, that doesn't tell me what the minimum is. It doesn't tell me how to find it even, but at least it gives me what it is I'm trying to optimize related to the variables in the problem. That's what I'm looking for, is an equation that has what I want optimal related to the variables I'm going to use. All right. The purpose of this, they always hold something to be true. The purpose of that is to allow you to put one variable in terms of the other. It doesn't matter which one. I can either get y is equal to something about x, or x is equal to something about y. For me personally, I think it's easier to say x equals 100 plus y. But every problem you get is going to have something along those lines. They're going to tell you something is true. The surface area of the box is 800 square feet. That's true. So then you can use that information to get one variable in terms of other variables. All right. In this case, the difference is 100. That's true. That tells me x equals 100 plus y. So what I'm trying to optimize now, which has three variables, can be simplified into x times 100. Oh, sorry about that. We're changing x, right? X is 100 plus y. So 100 plus y goes in place of x. Y stays y. And just like that, we get p is equal to 100y plus y squared. We want to limit the number of variables. So the fact that they give you is going to be used to limit the number of variables. To take you from too many variables, which is 3, could even be 4 or 5, I don't know, it depends on how challenging these problems get, but in this case 3 variables would not be very useful. Use the fact to limit it down to 2 variables, and now what I'm trying to optimize is related to a single variable. At this point, I want to do a derivative. I'm trying to find the minimum. The minimum occurs when we go from a decreasing interval to an increasing interval, right? What we've already learned about graphing. So if I do p prime is equal to 100 plus 2y, and I set that equal to 0, because we know critical numbers occur at 3 scenarios. Scenario 1 is an endpoint, which we don't have. Scenario 2 is undefined, which polynomial functions aren't undefined, right? Scenario 3 is the derivative equals 0. So that's the only place it happens. In this one, if I solve this, I get 100 equals negative 2y, or 2y equals negative 100, take your pick. Divide both sides by negative 2, I get y equals negative 50. If I verify, that's only one critical number, right? If I verify that's the minimum, if I went from negative infinity to negative 50, and then from negative 50 up to positive infinity, and I established increasing and decreasing intervals, all right? I'm going to pick negative 51 here, I'm going to pick 0 here, and I substitute those into the derivative, 2 times negative 51 is negative 102, plus 100 is negative 2. 100 plus 0 is positive 100. So it decreases. At negative 50, it switches to an increase. And if it goes from decrease to increase, we're at a minimum, right? So that verifies that what we found was a minimum. Okay, the question asks us to find two numbers. We've only found one. So we also know y is equal to negative 50 is the minimum value of one of the numbers. 100 plus negative 50, which would be positive 50, is the other number. And that tells me that 50 and negative 50 be the numbers whose difference is 100. That product is a minimum. What's the product of these two numbers?
The product,
Of these two.
negative 250.
Negative 2,500 maybe? Right, that's the product. Now you don't have to do the product. I just wanted to verify that's the smallest product possible. And it seems like 2,500 is big, but negative 2,500. That's like, hey, how much money do you have? Negative $2,500. Yeah, you don't have a lot of money, right? That's a low number, all right? It's negative 20. It's like way down at the bottom, right? Pick a different number. Let's say let's say y equals 4. If y equals 4, x minus 4 equals 100, right? So x would equal 104, right? What's 104 times 4? 416, right? Which is bigger than negative 2,500, right? And if you did that to any random number that you picked, every product you get is going to be bigger than negative 2,500 because that's the smallest. Right? Again, that's what we're finding. That's what calculus finds for us immediately. We don't have to go through just randomly picking things. Right? We can immediately find that minimum. So negative 50 and 50 are the two numbers whose difference is 100. The product is minimum. So that's what our answer is right there.